Dear chemistry friends, happy Mole Day. As we all know, chemists across the world honor Avogadro's number, that is 6.023 into 10 power 23, by celebrating the number of particles that make up a mole from 6 hours 2 am to 6 hours 2 pm on the 23rd of October. The problem that chemists have with atoms and molecules is that they are a little on the small side, which can make counting them more than a little difficult. When carrying out chemical reactions, we often want to get some idea of how much of the product we can expect to get from a reaction. But the enormous number of atoms or molecules involved in even a small sample would make these calculations incredibly unwieldy. This is where the mole comes in. It's defined as the number of atoms or molecules present in 1 mole of a substance, 6.023 into 10 power 23. French scientist Jean Perrin proposed naming this number after AMEDEO Avogadro, the Italian scientist widely credited with being the first to realize that the volume of a gas at a given temperature and pressure is directly proportional to the number of atoms or molecules regardless of the gas identity. Hence we know 6.023 into 10 power 23 as Avogadro's number. Avogadro's number until 2019 was defined as being the number of atoms present in 12 grams of carbon-12. It's now defined simply as being 6.022140076 into 10 power 23 elementary entities. 1 mole of any substance then contains exactly this number of atoms or molecules. Obviously, dependent on the mass of the atoms or molecules, the total mass of 1 mole of a substance can vary. 1 mole of water weighs very marginally over 18 grams, whilst 1 mole of the salt you have in your kitchen, that is sodium chloride, weighs 58.4 grams. This can seem confusing for students of chemistry at first. As an analogy, it's easy to compare the term mole to the more everyday term a dozen. When someone says a dozen, you know they mean 12 of something. In the same way, chemists know that when they are referring to a mole, they are talking about 6.023 into 10 power 23 of something. Similarly, if you have a dozen elements and a dozen mice, you would expect the dozen elements to have a significantly greater mass than the dozen mice. However, despite the difference in mass, you still have a dozen of each. In the same way, the same number of moles of different elements and compounds can be different masses. Why do we need a mole? Well, for starters, it makes expressing amounts of chemicals a lot easier. We don't have to represent the number of molecules of a compound we have and use the large numbers that would entail, and we can instead use moles in our calculations to simplify them. We can find the number of moles of any mass of any compound simply by dividing the mass we have of the compound by the molar mass, and that is the sum total of the masses of the atoms that make up the compound. Additionally, using moles can help us easily predict the masses of products we can obtain from reactions. 6.023 into 10 power 23 is a huge number. It can be tough to wrap your mind around a number that is too big. To understand it more clearly, if you had 1 mole of marbles, that is 6.023 into 10 power 23 marbles, and you spread them all over the entire surface of the earth, you would produce a layer that's about 3 miles thickness. A mole of 3 centimeter long paper clips chained together would wrap around the equator 450 trillion times. A mole of cantaloupes 6 inches in diameter has the same volume as Earth, that is 1.1 into 10 power 12 kilometer cube. A mole of rupees distributed evenly to everyone in the world, approximately 7 billion people, would enable each person to spend 1.6 million per minute for an entire year. Talking about the name mole, it has nothing to do with the animal whatsoever. German chemist Wilhelm Oswald generally gets the credit for introducing the word. Ultimately, though, the word mole comes not from German, but from the Latin words moles, which means a mass. The word molecule is related to the word mole. It is the diminutive meaning a small mass. The mole day. Actually, the concept of mole day originated in an article in the Science Teacher in the early 1980s. Inspired by this article, Maurice Oller, now a retired high school chemistry teacher from Prairie du Chien, Wisconsin, founded the National Mole Day Foundation (NMDF) on May 15, 1991. In summary, the mole is a vital tool for chemists. Probably the reason there is a day to commemorate it, while its furious namesakes go the whole year unappreciated. So, dear friends, the chemistry community too has a personal holiday to celebrate, even though we work on this day. Happy Mole Day. Thank you.